So, in the previous parts we've looked at mean, median, mode and range, established when you can use statistics, when they are true but useless, and when you have to peel back extra layers of the onion. But now we're considering a situation where we have too much data. So, what is too much data? Well, I'm going to give you a scenario and we're going to try and work through how we can solve a problem in a quick manner. So, here's our problem. I've got in front of me 300 people. Now, I want to record how many siblings they've got as fast as possible. What's the quickest way of doing that? Now, I'm going to have to get an answer from each of them, and I'm going to have to physically get their answer written down. If I try and write these numbers out one by one, what's going to happen? Is there a better way of collecting all this data? Well, I don't think I can afford to write down 3, 1, 2, 4, 5, 1, 1, none, 1, none, for 300 pieces of information. That's going to take too long. And one key part of collecting data is you want to be quick, or certainly within a reasonable time frame. So how can I do it? Well, here's what I'm going to do. I'm going to ask how many siblings people have. I'm going to start by saying who's got no siblings. I'm then going to take a tally of how many that is. And let's imagine that tally continues on. I'm then going to write down the frequency for that. So my tally totaled 38. I'm then going to do the same for one sibling. I'll record a really long tally. I get 102 who had one sibling. I do the same for 2, 3, 4 and 5. And actually no one had 5 siblings in my survey, and only 2 had 4 siblings. So I didn't go beyond 5, I stopped. I got plenty more tallies at 2 and a fair few at 3. So I had another 120 here. And I had 38 again here. So, what I've actually got here is a nice frequency table. This is the number of siblings each person had, and this is how many times each of these answers was given to the question. So let's be clear. 38 people had no siblings. 102 people had one sibling. 120 people had 2 siblings. 38 people each had 3 siblings, and 2 had 4 siblings. So, the frequency table, ideal for collecting our information. Of course, now we're going to want to do some analysis within that. So, let's look at another set of data and do another frequency table for us to use. So here is another set of data on siblings. So let's set up the same table we just saw, and let's do this one live. both the table and then the follow-up data. What were the possible answers for the number of siblings people had? Well, in this case, those are the numbers. How many zeros were there? So, 1, 2, 3, 4. And ones, 1, 2, 3, 4, 5, 6. Twos, 5. Threes, 1, 2, 3, 4. And fours was just 1. Check you've crossed everything off. Okay. Let's try and find our 4 values now. Mode, median, mean and range. Start with the mode. Which was the most commonly occurring number of siblings? Which was the most commonly occurring number of siblings? Well, that's going to be 1. Because that happens 6 times. Okay, I'm going to jump down now and tackle the range with you. So, what is the gap between the highest number of siblings and the lowest number of siblings? And listen to the wording. It's the highest number of siblings and the lowest number of siblings. So it's this column we're focused on. So it's 4, because it's 4 take away 0. So far so good, hopefully. Now let's do the median. So there were 20 bits of data. If I was to line them up, I could put 10 on this side and 10 on this side. And then what I would need to do is go in between the middle bits to find the median. So I've got 4 zeros, remember, and then 6 ones. The next value is a 2. That's 4, that's 6, so that's 10. The next are 2s, then there's 3s, then there's a 4. So it's between a 1 and a 2, which is 1.5. So a reminder again, there are 20 people involved. So getting halfway between the data means half on each side, so 10 on each side. There's 4 in here, which is 4 zeros, and 6 here, so that's 10 people in total, and that's the lowest numbers. So the 11th person is in here, so it's between those two. Now let's have a look at the mean. Well, that's the sum of the values divided by the number of values. So what's the number of values? Well, that's definitely 20. How do we find the sum of the values? So, these 4 people here, who each had 0 siblings, how many siblings do they have in total? That's right, they have none in total. These 6 people, who each have 1 sibling, how many do they have in total. That's good. They have 6. These 5 people each have 2 siblings, so that's 10 in total. These 4 people each have 3, so that's another 12. And the last one person has 4. So the total number of siblings is here. 32 in total. Now people will call this column on the end lots of different things. I'll call it total for the row. You can call it whatever you wish. Now I'll take that 32 and divide it by the number of bits of data, which is 20, and I'll get 1.6. So that is my mean calculated. Just talking back through that again, the mean is the sum of the values divided by the number of values. The number of values is how many bits of data I've got, which in his case was 20. I can also find that here. This is the number of values here. The sum of the values is how much does each row add up to. Now these 4 people each had none, so there were none. These 6 each had 1, that's 6. 6 times 1. These 5 each had 2, 5 times 2. So each of these numbers here is our result of a multiply. Then when you add those up, you get the sum of the values. It's well worth you practicing this now and making sure you're confident with the calculation. Before we do that, there's a major error that people make that I need to tell you about. Lots of people will get the 32 correct. Then what they do, rather than counting how many bits of data they've got, getting the number of values from here, what they do instead is they go 1, 2, 3, 4, 5 categories and divide by 5, which gives them 6.4. Now look at all the actual individual data at the start. Could the mean be 6.4? Well, if your highest value is 4, the average can't be 6.4. So, when you're using a frequency table, the mean is the sum of the total rows divided by the sum of the frequency. There's the sum of the frequency for the number of values, and the sum of the total rows is here. It's worth practicing this now, doing 2 or 3 questions to get yourself up to speed. And then we'll later on look at how you can reverse this process to do some tricky problem solving.